Lesson 3-2. So what are we going to begin today? And the unit of trigonometric and polar functions, we're going to begin with our trig functions. Today, we're going to learn specifically, I'm going to jump down to learning goal number 3 about the sine, cosine, and tangent functions. But to learn about those and how they work, we first need to do a couple things. One, we're going to review what we learned in geometry, and I'm going to make some adjustments to the way you were taught. Not that you were taught wrong, but there's an easier way of learning this. And secondly, we're going to explain what this thing is called a radian and why it's going to be so important for pre-calculus. And then we'll finally get to really working our sine, cosine, and tangent. So that's the plan for today. Here, some vocabulary that's important to process through and talk about. Let me scroll through here so we can see it all. Oops. So first, the word you see here, standard position. What that is in standard position, angles are going to start on the positive x-axis. That standard position means angles are going to start here. That's what that means if you see standard position, is that our angles will start right there. This is going to be the starting location for standard position. An angle whose vertex is at 0, 0, it says, the angle will start there. And the initial ray, this right here, this is called the initial ray. The initial ray is the positive x-axis. Okay, that's standard position.
What's a ray?
Oh, good question. A ray is like a line, except it goes one direction. So one end is a endpoint like that. A ray has an arrow going the other way. So great question. So like a sun ray, the reason we call them rays is because they start at the sun, but they go forever the other direction, whichever way they start at.
So the angle, I don't know the angle.
The angle is going to be in between the two rays. These are like the sides of an angle, if you will. It's like the side. There's one side and this is the other. So while we're on that, if this is the initial ray, they call this other one the terminal ray. Now, if you look up here, it says initial side, terminal side. That vocabulary from AP Classroom is talking about triangles. The problem is, I say the problem, AP pre-calculus actually does nothing test-wise on triangles. Test-wise, they're going to be triangles are going to be in Unit 4, which you're not going to be tested on. So what I'm going to use here is the vocabulary that you're going to be tested on. They use the term initial side, terminal side, but that was for triangles. When I'm going to write it in here, whoops, I wrote side. I meant to write ray. Sorry, my bad. Correct that. Terminal ray. Terminal means to end. So that means that this initial is where the angle starts. This is where it ends. That's standard position. Starting on the positive x-axis, ending somewhere else. That's terminal, initial terminal. Okay, coterminal. What does it mean to be coterminal? Co means together. It means two angles that have the same initial location, the same initial ray, and they have the same terminal ray, but they get there by a different path. So for example, if you have this angle here, you'll learn that this is a positive angle because positive in math are ones that go counterclockwise, means against the clock. That would be positive. Something that's coterminal would be the negative angle that goes this way. That would be coterminal, the negative angle that goes this way. Negative because it's going like a clock. The negative angle that goes here is coterminal with this one because what does coterminal mean? They have the same initial ray and the same terminal ray. You might be saying, well, why do we just say coterminal? Why not initial as well? Because in standard position, they always have the same start, but not every angle has the same ending. They all start here, but they don't end in the same location. They all start on the positive x-axis. So for that reason, it's coterminal. That's telling you, we already know they start in the same spot. This is telling you they end in the same spot as well. So coterminal, what does it mean? Two angles that end in the same place. They start in the same place, they end in the same place. But the angles themselves go either a different direction or maybe they make multiple loops around the circle before they end their location. Okay? Finally, reference angle. This is extremely important to you. What is a reference angle? A reference angle is the angle from the terminal ray to the nearest x-axis. So for example here, you see how this terminal ray is right there? The reference angle is the angle that goes to the closest x-axis, which here would be the negative x-axis. And they're going to use the symbol of a theta with a apostrophe like that. Now, we will always call this a positive angle, never a negative. But that is the reference angle. It's from the terminal to the nearest x-axis, always expressed as a positive angle. That's going to be very important to us as we move on. So there's your vocabulary for finding angles. Now, notice I have some other letters in here that are going to come up throughout today. I'm going to explain those in the next slide. All right, so if you have that, you have your vocabulary visually filled in. Let's now look at the second slide. In the second slide, I'm going to introduce this word radian. It's extremely important. Now, first question for you. What does the word radian sound like to you?
Radius.
Radius. Now, this is brilliant. Watch this. Come over here to this little graph. I gave you one radius. Okay. Now, let's say I wanted to start drawing along my circle. I'm going to switch colors. I'll go red. I'm going to start drawing along the circle. And I want you to tell me to stop drawing when you think I've gone approximately the same distance as this radius. If this radius, for example, on your packet was 1 inch long, tell me when you think I've drawn 1 inch along the outside of my circle, the circumference of my circle. Tell me when you think I've matched the same distance. Like, for example, now, is this red curve about the same distance as here? Is it a little too small, a little too long, or is it just about right? I would say it's a little small as well. Let's add a little bit more to it. What about right there? What do you think? Is that maybe about the same? How many think it's pretty good? How many think a little too short? How many think it's a little too long? Okay, if anything that's a little bit too short, people say, let's add just a little bit more to it, and I'm going to stop there. Draw a little marker there and put that this is 1 radius in length. Put 1 radius. Now, I'm going to pick up and I'll start drawing again. Now, tell me when you think I, again, travel 1 radius in length. Another radius. So I'm going to pick up from that last spot. Tell me when you think I've gone another radius around the circle. What do you think right now? Gone far enough or a little bit more? A little bit more, maybe right there? I'm going to be too far. I know it. It might be this one's too far, but I'm going to just mark it right there so I don't get myself in trouble later. So I'm going to stop there. So if this was 1 radius, how far have we gone total? Remember, you always start here. How far have we now gone? Okay, now this is going to be weird, but I'm going to write 2 radiuses. Now, a lot of you are smart, and you're probably going, that is terrible English. It would not be 2 radiuses. It would be 2 radii. You're correct, but I'm not going to write that. Just leave it for radiuses right now. 2 radiuses to right there. Now I'm going to pick up, and I'm going to keep drawing. Tell me when you think I've reached my 3rd radius. Well, no one said anything. I'm going to say it right there because I need it to be somewhere like above this line. So put it right there and put right now, add in 3 radiuses. I know it sounds weird. We'll scratch out radiuses in a moment, but put 3 radiuses. Now, here's my question for you. How long do you think it would be to get to that point there? How long would it take to go from the start here in the initial standard position all the way around halfway? I shouldn't say all the way around, halfway around the circle. How long do you think that would be? Oh, I heard great guess right there. What do y'all think? About 3.1 radiuses, 3.2 radiuses? How many radiuses do you think it would take? It'll take pi radiuses. It'll take pi radiuses to get to that point right there, pi radiuses. So if you've ever wondered, where did the number pi come from? I have pi written in the back of my classroom. If you look, it's colorful. You see the pi symbol. If you look, you can notice there's something like black kind of going along in lines on there. If you got closer to that poster, it's all the numbers of pi. They just go on and on and on and on forever. If you've ever wondered, where did they come up with this number of pi? Did someone just start writing down a bunch of numbers and they said, hey, pi? That's not the way it worked. The way pi works, what pi really is, if you want to know what is pi, someone might say, well, it's 3.14. Okay, that's its number. But what is pi? What is it? It's a measure of radiuses around a circle. Pi is the number of radiuses it takes to get halfway around the circle. So let's do some brilliant math. if it takes pi radiuses to get halfway around the circle, how many radiuses would it take to get all the way around the circle?
6
2 pi's. Put 2 pi down over here. Put 2 pi, and you can write it right next to the 360 because we're going to say 2 pi equals 360 degrees. And so we're about to come up with a conversion here in a moment. But pi, what is pi? It's a measure of radiuses on a circle. Now, radiuses is a hard word to say. It just sounds weird. So I told you the true word would be radii. But we actually call it, when we're measuring on the outside of the circle, they won't use the term radiuses anymore. They'll use this word right here that I circled. They're going to say it's a radian. So what is a radian? A radian is a measure of a radius on the outside of the circle. I'll say it again. A radian is a measure of length of a radius on the outside or the circumference of the circle. So let me put this together. How many radians does it take to get halfway around the circle? Pi radians. How many radians does it take to get all the way around the circle? 2 pi. So a radius and a radian are very similar. What's the only difference? A radius goes from the center of the circle to the outside edge. That's what a radius does. What's a radian do that's different? Same length, but it now goes around the circle. All right. Some conversions we need to know. The easiest conversion is right here. That 180 degrees is going to be equivalent to pi. These two right here will be equal to one another. Pi will be equivalent. Let me just write up here. 180 degrees is going to be equivalent to pi. Now here's what you don't know and what doesn't come up for you testing, but I'm still going to tell you because I think it's important for you just to know this. Degrees we use when we're using a triangle. Mathematically, calculators are set up that if you're using a degree, it's going to calculate as if it's a triangle. And there's a difference. Triangles have straight lines. So if it's finding, as you're going to learn today, trig finds lengths and angles. If you're using a triangle, it's going to expect things to be straight. Radians, which is pi, go with a circle because look at the circle. Is anything on that circle straight? Everything's curved. So if you want an accurate measurement, you have to be in the right mode depending on your shape. You in AP pre-calculus will only be tested on a circle, which means you are only going to be needing to know which one of these two. Pi. You're only going to have to know pi because that's all they're going to test you on is circles. When we get to unit 4, I'm going to teach you some triangles and that, but they don't test you on unit 4. Does that make sense? So, are degrees important? Yes. If you want to be an engineer, you better know how that works. So that's why I'm going to try to show you some of it. But if you just want credit for my class, do I need to know how a degree works? No. But what do you know? I need to know how it works. Pi. And where does pi come from one more time?
The radian.
From radiuses it took to get halfway around a circle. That's it. So now, I told you I was going to fix this on the notes. Let's fix it now. We put this as 1 radius. You can say that equals 1 radian. And we would never say, ever, radiuses. We would say 2 radians. That's what you would say. That means it's been 2 radiuses. Instead of 3 radiuses, we would say 3 radians. Let's fix our notes now. Anything else I need to get on this? No, this says here again, positive rotation, angles move this way. If they're positive, you rotate around the circle that way, as I showed you on the previous slide. Yeah. Okay, if 1 pi is 180 degrees, let's do some quick math. If 90 degrees is half of 180, how many radians is 190 degrees? It'll be pi over 2. But the 90 equals pi over 2. And finally, the last one we need to add is 270 degrees would be the same thing as 3 pi over 2. That's because it's 1 pi plus another half a pi. So it's 3 halves of pi. All right, I think we completed our notes. I'd like to say, hey, let's stop there, but we haven't done any math practice with it. So let's go start practicing. You now got the vocabulary, you now have all of that. Let's just start practicing with it. First thing we're going to do is we're going to sketch each radian measure based on the on these little coordinate planes. Okay. So the first one up is negative pi over 4 radians. Now, what some students need to do early in the year until they really figure this out is to convert it to degrees. If you are going to convert to degrees, here's how you would do so. You would take negative pi over 4. And again, you're not tested on this. So you don't have to know how to do this, but this just might help you, is to think in terms of degrees. What you would do is if you want to cancel radians and change to degrees, what you do is, if you think of your chemistry class, when you want to cancel one type of unit, you go diagonal. I would put pi down here because remember, pi is equivalent to 180 degrees. If I want to cancel this pi, I would put pi down there and 100 degrees up in the numerator. Now I could go to my calculator and I'm going to multiply this out. And we're going to find out how many degrees this is so we can draw it properly. So I'm going to take negative pi over 4. Actually, my pi's cancel. I'm not even going to type pi in. My pi here and my pi here is going to cancel. So what I'm going to type in is, here we go. Sorry. Oh, menu, calculator, negative. And since my pi canceled out, I'm just going to put 1 over 4 times 180. And I get negative 45. This is equivalent to negative 45 degrees. So how would I graph that? Well, if it's negative, that means the angle goes clockwise. So I'm going to move this way. Now, how far is 45 degrees? I'm going to get a little, this is our initial side of the angle. This is always the initial side. Tell me when you think the terminal side has moved negative 45 degrees. There, perfect. I want you to draw something like that in your paper. Draw an arrow going down. And because we're going to be working with radians, put negative pi over 4. If you want to write the word radians, you can. A lot of stuff was going to get messy if we do try to do that all year. But that would be negative pi over 4 radians. We're not in degrees anymore. We are in radians. Okay, what about pi over 2? I already gave you that one. Do you remember where that was located? It's equivalent to 90 degrees. Now, you said it's positive. So which way do I rotate this time? Counter. So tell me when I go 90 degrees. There. Okay, I'm going to stop. You always start on the positive x-axis. Every angle will start there. And you curve, since it's positive, you go against the clock, counterclockwise, and that would be pi over 2. Again, you don't have to write radians. I'm going to. The pi itself is assumed, because a pi, like we said, is a measurement of radiuses. And so if you put the pi, it's assumed it's radians, because it's a measure of radiuses. All right, finally, where would 1 pi radians be? Wouldn't it be 90 degrees? Wouldn't it be 270 degrees? Wouldn't it be 360 degrees? How many is pi radians? It is 180. It's half the circle. So I go around half the circle. I end this way. And so you would draw it like that. And you would add in an arrow pointing this way. And you could put in your pi. Again, you don't have to write the word radians. I will just here at the beginning. But if you are in pi, it's assumed it's a measurement of radiuses. So it would look like that. Now, let's use some words to describe this. Yeah, go for it. All right, so it talks about here on example 2, the minute hand on a clock. So if you think of a clock, I'm just going to draw a circle for a clock. Remember, a clock has a shorthand for hours. And I'm just going to put the hour hand right here. We'll just say it's about 2 o'clock. And it was at, can I do a dotted line? Yeah, here we go. Let's say we were at 2 o'clock even, and we move forward 15 minutes. Where would 15 minutes be? There you go. All right. So here's the deal. In math, we start here and move this way, but a clock goes this far. So how many radians will it have traveled? How many radians is that it traveled if you went this way? It would be pi over 2. Now, you would think in math it would be negative, but this isn't a mathematical problem. This is a real world problem. And real world, it's asking basically travels means distance, and distance is always positive. So that you would think of this as being negative, we're going to say the clock travels, the minute hand travels pi over 2 radians. And I'm going to do it as positive because distance is always positive. I'll put that in parentheses. Distance always positive. Okay, now this one might be getting a little bit more tricky. The first one was kind of a warm-up. It was a little easier for us. Let's think through 10 minutes. This time I'm not going to do the hour hand. I'm just going to do the minute hand. Okay, if we started at 12, like meaning there's no minutes whatsoever, and we go on. If that's 5 minutes, if that's 15 minutes, 10 minutes is somewhere in there. Would y'all agree with that? Okay, let's think through. How can we figure out how many radians that is? I think it's 45 degrees. It's actually not 45 degrees. It's a good guess. Ruby, what did you think?
36.
Ruby. Come on now. So think of it this way. How many minute markers are there around the clock? If this says 12, most clocks don't have minute markers. Well, I guess they might have a little bitty. If you look at it, no, digital clock. You usually have a 12, and then you have a 1, then you'd have a 2, then you would have a 3, and so far. There's 12 numbers around there. How far have I moved so far? 2 out of 12. I'm going to do this as a proportion. I've moved 2 out of 12, and now here's a different question. In radians, how many radians are there to get all the way around the circle? 2 pi. So what I could do is a proportion here, and I'm saying I'm turning 2/12 of 2 pi around the circle. That's what I'm doing, and I'm going to get my answer this way. So what is 2 times 2? So it'd be 4 pi over 12. Can I reduce that? Yes. And what is, how many times does 4 go into 12? 3. It's pi over 3. This would be pi over 3 radians. So earlier I said, I did hear 45 degrees. I said no. I heard 3/4 pi. I said no. Pi over 3 is 60 degrees, and that's what that is. That would be a 60-degree turn. Okay, and one more time. You might have figured out how much it's going from looking at these two, but in case you haven't, let's do one more here. What about in 5 minutes? So we're looking at the distance traveled from, if we started at the 12, and now you're pointing at the 1. From the 12 to the 1, what is that distance traveled? That's the question for us to solve here. How could we do that? Do another proportion? How much of the clock did we travel by proportion? 1/12. Okay, how much would it be to go all the way around? 2 pi. So if I multiply that out, 2 pi over 12, can that simplify? 1 pi over 6 radians, that's right. And that would be the answer this time. Which is equivalent to how many degrees? Again, you don't need to know this for my classwork, but you should know this if you want to use this in real world. How many degrees are in pi? 180. What's 180 divided by 6? 30. That would be a 30-degree turn. That's correct. All right. With that, we come to our first DOL. First two DOLs. So here, I've given you a degree measurement. I know I told you you're not going to be tested on it, but I still want you to know it. So I'm going to give here a degree measurement that's going this way. And I want you to figure out what would be this angle measurement in radians. And then another little math question for you to figure out here. Again, in radians, I want you to try to figure out what would this angle be there. A DOL number 1. Go for it. All right, let's take a look now at example 3 here. Before we start example 3, we now get to bring in trig. This is the fun part. To me, this is the most fun thing about all of pre-calculus right here. Starting here, what do engineers, artists, airline pilots, carpenters, golfers all have in common? They all have to work with angles. So earlier, I told you on this model, we drew some things and added into them. What I'm now going to do is describe to you the 6 trig functions and how they work. As I told you, in the real world, oftentimes we use angles that are in degrees. In AP pre-calculus, we're not going to be using degrees. What are we actually going to be using? Radians. Okay, some very important relationships you need to know. Sine is going to be your y component. I sent this out by remind to you. Sine is y. What is sine? Y. Cosine is x. Tangent is y over x. Now, you have that written down here. Now, here's the deal. Most of the stuff we work on in my class is going to be on what's called a unit circle. That means a circle that has a radius of 1 unit. A unit circle is a circle that has a radius of 1 unit. So watch what happens mathematically over here in a second. So this is, I'm just going to write here, unit circle up above it. If it's a unit circle, what that means is the radius is what? How much length? 1 unit. I'll go ahead and put 1 unit there so you see why it's called a unit circle. Now, if that's the case, if r equals 1, come over here. Tell me, what could I reduce sine to be if r was 1? So sine will be y on the unit circle. What is cosine going to be if r is 1? Sine is y, cos is x, tangent will be, does that have an r? Y over x. Okay, you're going to hear me say this 1,000,000 times this year. Okay, I exaggerated. You're going to hear me say this 900,000 times this year. Okay, I'm still exaggerating. You're probably going to hear me say this approximately 300 times this year. What are you going to hear me saying? Sine is y, cos is x, tangent is y over x. If you ask me a question, I'm going to look at you a lot of times this year because it's going to be the answer to so many questions, or that's going to be the starting point. I'm going to say, well, what is sine? And what do I expect you to say? Y. Cosine, what is cosine? Tangent is y over x. Now, a little helpful way for you to cheat right now to get it down. Go to your calculators, press the trig button. Open up your calculator. You'll have to get to like a graph or a calculator screen. Press that trig button. The way to cheat at the beginning of the year is it gives it to you in order. What's the order? And by the way, the order's the same on your cell phone, calculator you have, you know, at your house, whatever. It's always in the same order. What order do they display the trig functions here?
Sine, cos,
Sine, cosine, tangent. Now I'll get to the other 9 here in a minute, but sine, cosine, tangent. That's always the order. Sine, cosine, tangent. And then it always goes sine is y, cos is x, tangent is y over x. Same order. Y first, x second. Sine is cos is, what in the world is going on? Cos is x, tangent is y over x. Sine is y, cos is x, tangent is y over x. Another way, if you panic, tangent is your slope. Why do I say slope? What was the definition of slope in algebra 1? Rise over run. Change of y's over change of x. It's slope. It's the order of slope. Tangent is slope because it's y over x. Tangent is your slope. That's what it is. What is tangent? Your slope. It's the y over the x. Sine is y, cos is x, tangent is y over x. That's the order. Y first, x second. Y first, x second. Sine, cosine, tangent. Press if If you get messed up in your brain, just press the trig button and you'll see them in order right there in your calculator. So one more time, what do you, sine is what?
Y,
Cos is,
X,
tangent is?
Y over X.
Okay, now that's on a unit circle. Will every circle that we ever have a radius of 1?
No.
So the only thing that different that happens if our radius gets bigger is you just divide y by r and x by r. That's the only thing different. Is if your r turns out for whatever reason, we'll have a lot of problems where it's not. All we'll do is instead of saying sine y, it'll be okay, sine y, but then we just divide it by our radius. Cos is x unless the radius is bigger than 1. Then it's just going to be x divided by radius. But tangent will not change. Okay? These next three trig functions, we're going to talk more about those later in the year. Right now, I'm just going to show them to you. They are the reciprocals. This is called cosecant, CSE. Notice it's the reciprocal. What was sine's ratio over here?
Well,
Y over R. What's the ratio over here?
R over
R over Y. It's just the reciprocal. They flip the fraction. This was x over R. What is this one?
R,
R over X. Over here, it was Y over X for tangent. What is cotangent?
X over R.
X over Y. Okay. I don't know if I have time. If I do, I'm going to show you a cool calculator I created to show you by picture what do they all represent when you look at a triangle and a circle put together. It's pretty neat. Hopefully I'll have time to get there to show you. It's just good learning. All right, let's go back to geometry. How many of you remember your geometry teacher well? Show of hands. Now, some of you had me in the summer, and so I just taught you the way I teach it. Others of you learned SOHCAHTOA. How many of you remember your teacher talking SOHCAHTOA? I will not use SOHCAHTOA in my class. I use sine y, cos x, tangent is y over x because it's a lot easier. But if you know SOHCAHTOA, here's what you learned. I want to blend it in right now. We're going to be dealing with triangles this semester. Is that what we're dealing with in AP or testing over?
No.
What do you get tested over instead? Circles. So what you could do here to tie this in, this is for your sake. Draw a circle that connects the circle. This is the the origin, the center of the circle. Put right here, origin. Try to draw a circle. You can see on mine how it's supposed to look. I should have put this on yours, wasn't thinking. Which means the hypotenuse is no longer a hypotenuse. What would we call this instead? A radius. What you called opposite on this circle, let me add 2 more lines. What your teacher called opposite is now, is that as an x value or a y value? It's a y value. So I'm going to say y is the opposite. What about adjacent? Is that an x value or a y value? That's an x value. And notice if you go through here, you hear SOHCAHTOA. If you remember, if you're like, what's SOHCAHTOA? I don't remember my teacher telling me. It was that sine was opposite over hypotenuse. That's so. Cosine's adjacent over hypotenuse. Tangent is opposite over adjacent. TOA. SOHCAHTOA. That's what it was. Well, now check this out. What is opposite? Opposite is y. Hypotenuse is r. Radius. Adjacent is x. Hypotenuse again is r. Opposite is y. Adjacent is x. Guess what we stumbled onto one more time? What is sine? Y. What is cosine? X. Tangent is. The only thing I would do different if AP Pre-Cal's changed tomorrow and said, you know what, we're going to test students on triangles. You got to take the triangles. The only thing I would do is I'd say, okay, mathematically, the hypotenuse is the same thing as a radius. If you walked into a regular pre-cal class, literally right now, teaching the same thing, but they're tested in Dallas more on triangles. I don't ever call it a radius. I call it all year a hypotenuse. And so we don't use the letter R in that class. You know what letter we use instead? Yeah, hypotenuse. We use an H. So if you look back on, some of those got stolen. I forgot. Never mind. I was gonna say look back in the year. They used to have them in H's, but I forgot they got robbed over the summer. Anyways. Do you kind of get what I'm talking about here? What is sine? Well, it's the y component. What is x? Cosine. I said that backwards. What is cosine?
X.
X component. What is tangent?
Y over X.
Y over x. So y over x will be the Slope, the slope. All right, here we go. Find the values of sine, cosine, and tangent for each of the given angles. All right, so how easy is this on a unit circle? This is a unit circle. Do you know how I know this is a unit circle?
The radius.
Yeah, why is it? Because you told me the radius is 1. If it's a unit circle, well, guess what? Sine is y. This right here is the sine. Sine is y in a moment. Sine is y. Well, what is the x? Cosine. That's the cosine. This problem says find the values for sine, cosine. This is sine. This is cosine. And I should be saying pi over 6. Sorry. Let me change this to pi over 6. Cosine pi over 6. Sine of pi over 6. There we go. Let's make this more accurate. That's sine. That's cosine. Sine is y. Cos is x. What is tangent? Okay, so I'm going to give you a shortcut in a moment, but first, just to see it, let's do it long ways. What is the y value?
1/2.
1/2. What's the x value? Okay, now that's what tangent looks like right now. But we can simplify that. If you remember a fraction divided by a fraction, another way of doing that is to take the numerator and multiply by the reciprocal of the denominator. So what I have here is equal to this. I took the numerator, left it alone, but instead of dividing by the denominator, I'm going to multiply by the reciprocal. What can I do with the 2's? Cancel. So I have 1 over square root 3. And what we're going to learn as the days go on is we'll never leave a square root in the denominator. So what happens is to get rid of that, I have a shortcut that I'll say I'll shoot it up, but here's what we do. Technically, the way to do that, get rid of a square root in the denominator, is you multiply top and bottom by that same square root. Now, why do I do this? I'm technically multiplying by 1. Square root of 3 divided by square root of 3. What is the square root of 3 divided by the square root of 3?
1.
It's 1 because it's being divided by itself. But if I multiplied straight across, I would get the square root of 3 over the square root of 9. What is the square root of 9? 3. And so our final answer here for tangent is the square root of 3 over 3. I'm going to go ahead and just put that over here. Tangent of pi over 6 is equal to the square root of 3 over 3. There's the tangent. Here's the cosine. Here's the sine. I told you there was a square root at the there's a shortcut at the start. What's the shortcut? When you're working the unit circle, when you do tangent, just ignore the denominators. It's y over x. If you check all my work, if you just took the y, what? If you just took the y, the original y that's in the numerator, and divided it by the original x in the numerator, just those two, y over x, look what you get. You see how you get all the way to that step? Saves you a lot of time. That's the shortcut. When you do tangent, ignore the denominators. They will cancel each other out every time. Because it'll be the same denominator every time. They will cancel each other out. And so it's just the numerator y divided by the numerator of x. That's how you'll do it. And from there, you can simplify. Okay? Question over that? Let's pick up and go to the next one. All right, what about pi over 4? If I define the sine, cosine, tangent of pi over 4, what is going to be the sine of pi over 4?
What?
The y value. Very good. So in this case, the y value is this. The sine of pi over 4 would be equal to the square root of 2 over 2. What's the cosine of pi over 4 going to be?
Square root of 2 over 2.
That's right, because sine is y, cos is x. Cosine of pi over 4 is going to equal the square root of 2 over 2. Oh, Kevin, you're good to go now. Okay, what about tangent? What's the shortcut if you're doing tangent? The numerator of y divided by the numerator of x. So what's the numerator of y? Square root of 2. And the numerator of x? What is the square root of 2 divided by the square root of 2? 1. And so tangent there is 1. So what does that mean? That's telling you the slope of this line right here. What's the slope of this line? 1 over 1. I didn't write this in on the first problem. I'm going to do it now. Here, just do this. Make it like a triangle here in your notes. Take this point and just make a triangle from that point to the x-axis. You always connect to the x-axis. That's the reference angle. Remember how I said the reference angle connects it to the closest x-axis? Draw a reference triangle is what they call that. Here, what we just learned, this radius is 1. The y value here would be square root of 2 over 2. This x value would be square root of 2 over 2. That's the lengths. This is 1. This is square root of 2 over 2. This is square root of 2 over 2. The other triangle, the other problem, sorry, is not a triangle yet. Let's make it a triangle. If I made it a triangle, you would connect it always to the x-axis. What this states is this radius, this hypotenuse, is 1. The y value is 1/2. This x value is the square root of 3 over 2. That's its length. That's its length. That's its length. If you did the Pythagorean theorem, a squared plus b squared, you would get c squared of 1. Okay, I don't know if I'm losing you or if it's making sense, but that's how the trig works. All right, next slide. All right, what about here? Sine, cosine, tangent. Again, this is a unit circle. How do I know it's a unit circle? It's a radius of 1. So how can I find my sine? Sine is x. Sine is y. Okay, so sine of my theta in this problem is 0. Sine of 0 equals how much? 0. Okay, what about cosine of 0? Good. Tangent would be 0 divided by 1. What is 0 divided by 1? This line, what's the slope of this line? 0. It's flat. It's constant. It's flat. So it's a slope of 0. So tangent is your slope. All right, let's do another one. Tell me right now, this slope, is it going to be positive or negative?
Negative.
It's a negative slope. By the way, you can't draw a triangle there. Okay, here we go. 7 pi over 4. I'm going to write them up here. Sine of 7 pi over 4. Is this a unit circle? Yes. So I just have to take the y value. What's the y value? Negative square root of 2 over 2. That's sine of 7 pi over 4. What's the cosine of 7 pi over 4? Square root of 2 over 2. And finally, what would be the tangent of 7 pi over 4? What's the shortcut to find the tangent? You just take the numerators. You have to take the negative though. So it's the negative square root of 2 divided by positive square root of 2. So this negative you treat with the numerator, negative square root of 2 over square root of 2. What happens with that? And so what are we left with? -1. That has a slope of -1, that line there. If you wanted to turn this into a triangle, which again, one more time, you're not tested in AP pre-calculus on triangles. But if you were, this angle right here would be the reference angle. I'm going to put in theta with a apostrophe like that. That's the reference angle. It's the angle that connects the terminal side to the closest x-axis. This length right here is the x length. It's square root of 2 over 2 units. That's how far this side of the triangle would be. The hypotenuse of this triangle is 1 because it's the same thing as the radius. This length would be negative square root of 2 because over 2 because you're going down. It would be negative square root of 2 over 2 units going down. That's where it would be on the y-axis. So sine is y, cos is x, tangent is y over x. All right. I have a DOL for you. Go ahead and write out the sine, cosine, tangent for these two values. Moving on, example 4 here. Says given a point P, so any x and y on the unit circle corresponding to the angle theta in standard position, the sine of theta is equal to the what of point P? The sine would be equal to the y component. Let's try that again. The y component, that yes, the y value. The sine is equal to the y value of point V, the y component. It's technically the math word you should use, but the y value. Okay, what is cosine going to be equal to? The x component. The tangent of theta is equal to the y divided by x. Now, would I say components or component? Would be equal to the y divided by x. I'm going to put components because there's two of them. I need an English teacher to let me know if you'd still say component. That would be the tangent. Now, tangent is going to appear to be like what? The slope. Let's just put slope. All right. Now we're going to summarize a table here for values, and I want you to try to pick up the pattern as I do these. Now, there's a lot of words up here. I don't want you to get confused. Just look on here. I've already done the math for you. 0 degrees is equivalent to 0 radians. 30 degrees is equivalent to pi over 6. These are the conversions. I've already made them. That's because if you remember, 180 is the same thing as pi. 180 degrees is pi radians. I've already done this conversion for you. Now, I'm going to write this out, and I want you to see if you can figure out the pattern, okay? Here's sine. I'm going to give you first, it says to rationalize. I'm first going to give you the unreduced version, and then I'll give you the reduced version later if necessary. Sine is equal to 0 over 2. Actually, I'm going to do square root 0 over 2. Okay, in a moment I'll do it equals. Sine at pi over 6 is going to be the square root of 1 over 2. Sine at pi over 4 is going to be the square root of 2 over 2. Any predictions on what sine at pi over 3 is going to be?
Square root of 2.
And finally, last one. What about at pi over 2?
Square root of 4 over 2.
All right, great. Now this is how the pattern works. Now I'm going to reduce the ones that can be reduced. What is the square root of 0 over 2 reduced to become? 0. Because the square root of 0 is 0. You divide that by 2, you still get 0. Okay, what's the square root of 1? 1. So this reduces to become 1/2. This cannot reduce. This one cannot reduce. Square root of 4 over 2 can reduce. What's the square root of 4? 2. And what's 2 divided by 2? Okay. If you look at the reduced values, it's harder to see the pattern. If you pay attention to the reduced values, it's harder to see the pattern. If you look at the unreduced, it's very easy to see the pattern. What's the pattern? The square root just counts up. 0, 1, 2, 3, 4. Make sense? Okay, let me show you cosines. You ready to see cosines? Cosine works like this. Cosine starts at the square root of 4 over 2. So what are you going to guess, Evelyn, is this one? She's absolutely correct. What would you guess this one is? Square root of 2 over 2. Square root 1 over 2. And finally, square root of 0 over 2. Now we'll simplify. What is the square root of 4 over 2? What is the square root of 4? 2. 2 divided by 2 is 1. This does not simplify. Square root of 3 over 2 stays. Square root of 2 over 2 Does not simplify. It stays. Square root of 1 over 2 can simplify. What's the square root of 1? 1. And so it becomes 1/2. And finally, what's the square root of 0? 0. And what's 0 divided by 2? 0. By the way, these values you're going to have to know by the time we take our next test. So I'm going to give you a trick to kind of come up with these, but you need to know this pattern because you will be tested and expected to find these values without a calculator. Okay, how do we find tangent? It's y over x. What I'm going to do is start with the unreduced because it's easiest to come up with the pattern. The y is square root. Let me switch colors. I'm going to do the totally unreduced version. It'll be square root 0 divided by square root 4. What's the next one going to be? Square root 1 over square root 3. Next one. Next one. And finally. So I'm writing them out with the unreduced followed by the reduced versions so you get to see the pattern. Because the pattern's a lot easier to memorize with them unreduced as opposed to reduced. And then you can just reduce it on the spot. With tangent, the first one simplifies. What's the square root of 0?
0.
What's the square root of 4? What's 0 divided by 2? The middle one will reduce. What's the square root of 2 divided by square root of 2? When you divide something by itself, it becomes over here. What's the square root of 2? Square root of 4? 2 divided by 0 is 2 divided by 0 is not 0. Undefined. This one is not an equal sign. You would say that is undefined. Now these are going to still have a square root. 60 degrees is easier than the other. We cannot take the square root of 3, but we can take the square root of 1. What's the square root of 1? This just becomes the square root of 3. And I don't know if you remember this answer. We had it earlier. That's 1 divided by square root of 3. You cannot leave the square root in the denominator. So you shoot it up, and so it becomes square root of 3. The square root of 3 shoots up to the numerator. Square root of 1 is 1, and so that just disappears. The denominator, you just drop the square root. So it's the square root of 3 over 3. That's the version there. Now, in the following days, I'm going to give you a little technique thing to help you memorize it, but that's a chart there to help you out. As we go forward, I would recommend you pay attention to cosine count, sine counts up, cosine counts down. If you can get those two and you remember tangent is y over x, you can figure that out from there. Okay. Now, this thing is called a unit circle. I've given you the first value. What we're going to do is plug in the values going around to create our unit circle. Okay, so how's the pattern going to work? I know it says DOL. I'm going to start with you. What happens to the sine values? Do you remember? They go up. So you can look back and forth. The first sine value should be 0. The first cosine value should be 1. You see how that says 1 and 0? Cosine's x, sine is y. What's the next at pi over 6? What's that sine value there? 1/2. What was our cosine value at pi over 6? Square root of 3 over 2. Okay, now let's go on to pi over 4. What do you have for pi over 4? What was the sine of pi over 4? You can just look at your chart. Square root of 2 over 2. And what was your cosine at pi over 4? Square root 2 over 2. Good. Do you see how this works? Okay, skip over. I'm going to skip this one for a moment, let you fill it in. What would this point be right here? I'll give you a hint. It's straight up, and this circle has a radius of 1.
1.
Would it be 1, 0 or 0, 1?
0.
Okay, what's going to happen once you start over here is x's are going to be negative. Why are x's going to be negative? Because you're on the left side of the graph. Over down here, they're both going to be negative. Why are they both negative? It's left and down. And then when you get here, let's go ahead and fill in this point. What would the coordinates be for this point? 0, -1. And let's go ahead and fill in this point. What's pi going to be? -1, 0. Okay. When you get over here, it's just going to be y's that are negative. Y is negative here. Yeah, y's are negative when you're down low. X's are negative on the left. You can go ahead and fill in the rest there. I'll give you a moment to work on that. All right, the last thing on the notes that it says here, using your unit circle created on the previous slide, answer the following, or answer the determine where the following functions are positive or negative. Here's what I want you to do. Sine is which component? Y. Cosecant is also y. It's reciprocal. Where are the y's component? Where are the y's positive? In quadrant 1, 2, 3, or 4? Which quadrants are y's positive? In quadrant 1, whoops. 1 and 2. I want you to put pluses here. So what would be true of sine in quadrant 3 and 4? Put negatives. Okay, tell me about cosine. What letter is cosine? Where's x positive? Quadrant 1 and quadrant 4, which means where's it negative? 2 and 3. Now tangent is y divided by x. What's a positive divided by a positive? What's a positive divided by a negative? What's a negative divided by a negative? And a negative divided by a positive. There you go.